the last section in chapter 1 is 1.4, and it's a big section. There's a lot in this. It could have really been broken into probably a couple of sections. So this is a big one. There's a lot of videos under this one. Alright, so again, after this, then we'll have a test, so make sure you look over these and get ready and prepare. So we're going to look at functions some more, graphs of functions, and then rates of change and average rates of change. So we're going to identify linear functions and nonlinear functions. Look at slope as a rate of change, look at the graph of functions, identify increasing, decreasing, find average rate of change, interpret average rate of change, calculate the difference quotient. So there's a lot in here. Alright, so the simplest function, right, we talked about functions in the last few sections. So we're just looking at functions today, right, in this section. So the simplest function is our linear function. Alright, a linear function f is represented by the function f of x equals mx plus b, and that should be a formula you're very familiar with. That's the slope-intercept form of a line, right? Y equals mx plus b, where m and b are constants. As a linear function, the m and b values are very important constant. We'll talk about them in great detail. We'll talk about them a little bit in this section and more in detail in chapter 2. Again, we're going to focus a lot on rate, slope in this section, and the graphical properties of linear functions. A linear function, so first the slope, right? In a linear function, each time x is increased by 1 unit, and whenever we look at slope, that's what we want to look at. We're looking at the 1 unit increase in our x, in our input. When our input value increases by 1 unit, how does that affect our function value? Right? Well, that effect is the slope, right? The slope gives us how much our function changes, how fast our function changes, or how slow our function changes, in a positive or negative direction. And it's a constant when it's linear, meaning no matter where I'm at on my function, I am either increasing or decreasing at the same rate of change. Right? So again, that constant rate of change is that m in the formula. Right? It's that m value, which is very important, which is my slope. Right? It's how fast or slow my function's moving up or moving down. Alright, so how do we find slope? Again, slope is the equation of a line. It's constant rate of change, which means constant means I can pick any point on my line. Alright, so any point, and I'm growing at the same rate or I'm declining at the same rate. Alright, so I can pick any 2 points on my function to find my slope. Alright, so that's what we do. We find the slope of a line by taking 2 points that go on my line, right, that my line passes through. And it can be any 2 points. Doesn't matter because it's constant, so any 2 points work. And what slope does is it finds the change in y divided by the change in... That's what this is math symbol represents change. Right? It's a Greek letter, delta, and it represents change. So this is the change in y over the change in x. So in words, up top is always the change in y over the change in x. If it's a function, right, y is the function value, mx plus b. We can also write that as function notation. So it's the change in y, which can be the change in my function. So the bottom part's the same as the change in x. I take the x2 minus the x1 up top. If I'm given the function, sometimes I have to find the y values. Well, I do that by plugging them in. And so f of x2 minus f of x1 will give me my change in my function. Remember, the function represents the y value. So if I don't have the y value, and we'll do examples of this later on, if I don't have the y values, well, I plug them into the function to find the y values. That's all it is. And still means the same thing. It's the change in my function, change in the y values, the outputs, divided by the change in the inputs. So long as we don't have division by 0. That's what this last statement is. So long as x1 is not equal to x2, because if x1 was equal to x2, they'd cancel each other out here, and I get division by 0. Alright, so picture, right? Pictures are always useful, and we'll look at graphs. We'll actually find slopes where we're just given a graph. Alright, so my slope, so this is my function, f of x equals mx plus b, my line. That slope is, again, this formula, but if I use function notation, it's x2 minus x1, f of x2 minus f of x1, right? Because this is y2, this is y1. And so it tells the, in this case it's a growth, because that's the way it's drawn here, but this is the change in y, the moving up, and this is the changing x. So sometimes we write it in the simplest case, when usually you first learn slope, we talk about it as rise over run. All right, rise meaning I'm moving up. This would be the rise, the change in y. Run, again, would be the change in x. I'm running along the x-axis. So rise over run. And rise could also mean moving down, right? Moving down would be a negative direction, so it's how it's moving. Run, again, usually we run in one direction or the other. But again, depending on if I run left to right, it's the positive direction. If I run right to left, it's the negative. Right? In the rise, if I go up, I'm in the positive direction. If I go down, the rise is in a negative, right? Because I'm going down. It's not really rising, it's falling. And again, the slope can be negative in that case. Alright, some special slopes. Or, well, not really special slopes. I was talking about some slopes. So we can get two types of slopes. Either we can get slope that's positive. Right, my slope, my rate of change of my linear function is positive. So an example I have drawn here is this is a line where my slope is 2. Right, I'm going to look at it in terms of the function and how we get that. So I'm going to have these 2 points. And if I look at it in terms of rise over run, alright, so the rise would mean I'm going to go up here and then over to the second point that I've drawn there. And maybe I'll do that in a different color. Alright, and so this would be the change in y, the rise. This would be the change in x, the run. Alright, so the slope, if you're looking at it in terms of rise over run, I'm going up 2, right, up 2, so the change in the rise is 2, and I'm going over 1 to get to that point. And so there's my rise over run, which equals, if I take 2 divided by 1, it equals 2. And it's a positive number. I'm moving up, right? I'm moving left to right, I'm moving up at this given graph. And so that means my function f of x is increasing. Right, which I kind of summarize that down here. Alright, so positive slope, something that looks like that. I'm moving up. Positive slope is positive. It rises from left to right. If you look at the graph, it's a linear function. Its slope is 2. And what that slope means is that the function is increasing by 2 units, moving up by 2 units, for every change in x. And right, that's what we're doing. When x changes by 1 unit, if I go over 1 unit, my function goes up by 2. And that works every time, right? I go over 1 unit, I go up by 2. I go over 1 unit, I go up by 2. Right? And so everywhere I go over 1 unit, I go up by 2 to get my next point. Right, next one is the negative slope. So I'm moving in the negative direction. Right, so again, slope is negative when it falls. It's decreasing. It's moving down, left to right. Alright, so again, if you look at the graph, the linear function has a slope of negative 2. And again, what that means. So before I get to what it means, we'll look at the graph. Alright, so what it means is, this is when I'm going to get the negative, right? First of all, I start with a point that exists, so there's the point I'm looking at, and I'm going to go to this point. And so I go down and then over. And so this would be the change in y. In this case, my change in y is moving down. This would be my change in x. And so my slope, remember, is my change in y, my rise. In this case, my rise is moving down. My x is still running in the right direction. And so this time I go down by 1, over by 2. So that means down by 1, negative 1. Over by 2 is still a positive 2. And so there's where the negative 1/2 is. Negative 1 over 2. This would be my rise in this case. Again, it's a negative over my run. Alright, so negative slope always move downward. Alright, so if you're looking at the graph, the linear function has a slope of negative 1 over 2. And again, what that means, it's always important to understand what it means. That means that slope is telling me something important. That important aspect that it's talking about is the fact that my function, it's negative, so it decreases, and then I know how much it decreases. It decreases by 1/2 unit for every unit increase, and we always talk about it in a unit increase. So if x, if I go back here and kind of look at it, if I look at x, when I change x by 1, my function decreases by 1/2 of a unit. And so if I look kind of here, if I look at this point here, if I'm going to go over by 1, I decrease by a half. That's half of the unit. Again, if I go over by 1, I decrease by half a unit. I go over by 1, I decrease by half a unit. And that works anywhere on the graph. I go over by 1, my function decreases by half a unit. Right, that's what the slope is telling me. It's telling me how fast, which in this case is not super fast, my function decreases. Alright, so we're going to look at some special lines. So these would be sort of general lines, what most lines look like, either increasing, moving up line, a decreasing, moving down line. We're going to look at our special lines in the next video.